Hello students and subscribers, here is another sample problem video on indeterminate beams solved by slope deflection equations. Also remember that this problem was solved also by three moment equations, so we just verify that the answers are the same. So EI equals 100,000 kilonewton meter square. 200 times 10 to the 6 kilopascals times 500 times 10 to the 6 mm to the fourth divided by 1000 to the fourth to make it meter to the fourth. So 100,000 kilonewton meter square. And we have support settlements here. Remember the sign convention for slope deflection equation, clockwise rotation, positive. So MBA, because the far end A has zero moment, is 3 EI over L, so 3 100,000 over 8 times theta near, which is theta B, minus, because the rotation of AB in the settled supports is clockwise, so it is 7 mm, 15 minus 8 is treated positive, 7 mm is 0.007 over 8. The formula is minus, then delta positive 0.007 over L over 8, plus fixed moment at B, which is WL square over 12 positive, 28 8 square over 12 minus fixed moment at A, which is so minus 1 half, then the fixed moment at A is negative, it is at the left, negative 28 8 square over 12 by symmetry. Simplifying 37,500 theta B for MBA, the value here is negative 525 over 16, and the combined value of these last two terms is 224. So combining like terms, MBA is 37,500 theta B plus 3,059 over 16. Call that equation 1. MBC. BC is an interior span, so we expect moments at B and C. So therefore, formula is 2EI, 2 times 100,000 over L, 5. Quantity 2 theta near, 2 theta B plus theta far, theta C, minus 3 times delta over L. Delta is treated negative here, 5 mm the difference, or negative 0.005, because the chord joining BC is rotating counterclockwise. So it is treated negative. So minus 3 times negative 0.005 over 5. Then the fixed moment at B is negative 32 A 2 B 3 square all over L square 5 square. Simplifying 80,000 theta B plus 40,000 theta C plus 120 minus 576 over 25. So MBC is 80,000 theta B plus 40,000 theta C plus 96.96. Call that equation 2. MCB, on the other hand, we just interchange coefficients. So 40,000 theta B plus 80,000 theta C. Then 2EI over L times negative 3 times, it's the same, 120 here. But the fixed moment C is positive 32. So 2 is now squared times 3 over 5 square. So combining MCB is 40,000 theta B plus 80,000 theta C plus 135.36. Call that equation 3. Finally, MCD, again, D has zero moment, so it goes back to 3EI, 3 times 100,000 over L6. Theta near is theta C minus delta over L. Again, delta, because the chord CD rotates counterclockwise. Delta, which is 4 mm or 0.004 meter, is treated negative. So theta C minus negative 0.004 over L6. Then fixed moment at C is negative WL square over 30. Negative 36 6 square over 30 minus 1 half fixed moment at D is positive. So minus 1 half 36 6 square over 20 at this end. So remember the fixed moment formula for triangular loading. So simplifying 50,000 theta C plus the value here is 100 over 3 minus 75.6 combined value of these two. So MCD is 50,000 theta C minus 634 over 15. Call that equation 4. We then apply equilibrium at joint B. Equilibrium at joint B, MBA plus MBC equals 0. So MBA 37,500 plus MBC 80,000 theta B, 37,000 theta B 500, 37,500 theta B plus 80,000 theta B is 117,500 theta B, then plus 40,000 theta C, then equals negative 3,059 over 16, negative 96.96. The combined value in the right side is negative 115,259 over 400. Call that equation A. Then we apply equilibrium at C, MCB plus MCD equals 0. So 40,000 theta B, MCB, this equation 3 plus equation 4. So 40,000 theta B plus 80,000 theta C plus 50,000 theta C is 130,000. Then transpose this to the right, negative 135.36, then plus 634 over 15. The combined value is negative 6982 over 75. Then we solve equations A and B simultaneously. We can now compute theta B negative 2.46694 times 10 to the negative 3 radians, and theta C is 4.29567 times 10 to the negative 5 radians. We can now compute moments at B and C. For moment at B, it is moment BC, which is this, so 80,000 theta B. So 80,000 times negative 2.46694 times 10 to the negative 3 plus 40,000 theta C, 40,000 times 4.29567 times 10 to the negative 5 plus 96.96. So MB is negative 96.677 kilonewton meter, which is the same as that by 3 moment equations. And finally, M sub C, which is MCD, is 50,000 theta C, 50,000 times 4.29567 times 10 to the negative 5 minus 634 over 15. So therefore, it is negative 40.119 kilonewton meter, which is the same result as in 3 moment equation. So that's it for this sample problem video. I hope that you were able to follow the explanations and the solutions.